Hello guys, welcome to my online key facts in physics class. In our previous video, we looked at impulse and the definition of impulse, the formula for impulse, the unit of impulse, and a simple basic problem in impulse. But in this video, we'll be looking at Newton's laws of motion, the first and the second law of motion. But before we dive into that, I dropped an assignment with us in our last video on impulse.
Audio
And
Jungle.
I don't know how many of us that looked into that problem, but I would like us to solve that problem together before we dive into the Newton's first and second law of motion. Now, from that problem, we say that a ball of mass 5.0 kilogram hits a smooth vertical wall normally with a speed of 2 meters per second. Determine the magnitude of the resulting impulse. That was the question. So from this question, the first thing that comes to mind is the formula for impulse. Since the question is asking for impulse, and from our last video, we can recall that we gave two formulas for impulse. The first is that I is equal to Ft, and the second formula that I is equal to m open bracket v minus u. So from this question, we look at what do we have in this question and which of this formula would be the one to use in solving that problem. So we look at this question, a ball of mass. So we have a mass in this question, m. So we have m is 5.0 kilogram in this question. Hits a smooth vertical wall with a speed of 2 meters per second, with a speed of 2 meters per second. So speed is given to us, which is velocity, but we don't know if this is an initial velocity or a final velocity, but we are going to determine this from looking at our formula. So by looking at what we have in this question, what we are looking for I is impulse. So we really do not know if this is an initial velocity or a final velocity. But when we look at our formula and relate it to the question and what we have in the question, then we can determine whether this velocity is initial or final velocity. So from looking at what we have in this question, we know we have mass, we know we have velocity. So from that, we can simply deduce that this second formula for impulse is what we use, that I is equals to m, there is mass, and there is velocity. So this very first formula, there is force and there is time, but we do not know what force is, we do not know what time is. From the question, it wasn't given. So it clearly indicates that we are not using this formula, we are using this other formula. So we can wipe this formula out. So we know that our mass is I is equal to 5, open bracket. Then how do we determine if this velocity given to us is final or an initial velocity? Now, the velocity was given with a speed of 2 meters per second. So we are going to assume that this ball started from rest. Assuming that this ball started from rest. So it means that if this ball starts from rest, it means that the initial velocity will be equal to 0. So we can say that this is final velocity and initial velocity is equal to 0. So we are assuming that this velocity given to us is final velocity and the initial velocity is 0, assuming the ball started from rest. So we have 5 into our v is 2 minus 0, u is 0. So we have I is equal to 5 brackets 2 minus 0 is still 2. So we have I is equal to 10 Newton second. So that's how to look at that problem. Our answer is 10 Newton second. But today we are looking at Newton's laws of motion. Today we are looking at Newton's law of motion. First law. So according to Newton's first law of motion, that law states that a body will continue at its state of rest or motion in a uniform straight line except that body is being acted upon by an external force. How do we explain that? If I have a body here of mass m, according to Newton's law of motion, that this body will continue at a state of rest except an external force acts on this body and puts this body in motion. So it means that according to Newton's law of motion, that a body can assume two positions, either a state of rest or a state of motion, or a state of motion in a uniform straight line. Uniform straight line. So if a body is in a motion, moving in a uniform straight line, it will continue in that motion except another body acts on it. If a body is at rest, it will continue at a state of rest except an external force act on that body. A very good instance, if I drop this pen on a table, this pen will continue to remain on that table except there's an external factor, external force that acts on this pen to leave the table. Another instance, if I roll a ball, assuming friction is negligible or neglecting friction, when I roll a ball, of course, when a ball is rolling on the ground, the effect of friction between the ball and the ground will definitely bring that ball to a stop at some point. But assuming friction is zero and there's no external force acting on that body and that body keeps rolling, that ball keeps rolling, that ball will continue to roll till infinity on a straight line, except it is acted upon by an external force. That is simply what Newton's first law of motion is saying. Then, second law, Newton's second law of motion. According to Newton's second law of motion, it states that the rate of change of momentum with time is directly proportional to the applied force and takes place in the direction of that applied force. The rate of change of momentum with time, that is, a change in momentum with time. So a change in momentum, we already know is impulse, right? But this time around, there is time attached to it. So rate of change of momentum, this is change in momentum. mv minus mu from our impulse class, that's the previous video. This is change in momentum. The rate of change of momentum with time. So momentum is changing with time. So we are dividing momentum with time. Is directly proportional. Directly proportional. This is the sign of proportionality to the applied force and takes place in the direction of the applied force. So this can be written as F is equal to mv minus mu all over t. F is directly proportional to mv minus mu all over t. So if I want to remove the constant of proportionality, I will introduce. If I want to remove this sign of proportionality, I will introduce a constant of proportionality. So I say F is equal to k mv minus mu all over t. So this formula can be written as force k mv minus mu all over t. Of course, I can factor out m. So I have k, F is equal to k m bracket v minus u all over t. So assuming that k is equal to 1, that k is equal to 1, I will have F is equal to m v minus u all over t. 1 multiplied by everything here, we'll still have what we have there. So this is the formula according to Newton's second law of motion. The rate of change of momentum is directly proportional to the applied force and takes place in the direction of that force. So what this simply means is, if we have a body of mass m and velocity u, and then an applied force, according to Newton's second law of motion, the rate of change of this momentum, remember that the applied force to this body will change the momentum of this body. This body already has a momentum mu, and this force will bring about a change in momentum to be mv. So according to Newton's second law of motion, it's saying that the rate of change of momentum, the rate at which the momentum of this body changes from here, initial momentum, to final momentum, is directly proportional to the applied force. It means the higher the force, the higher the change in momentum. The lower the force, the lower the change in momentum. So the rate at which this mass changes momentum is directly proportional to the applied force. So the degree of force that I apply on this body is the degree at which this body will change position or will change momentum. And this body, the change in momentum will always take place in the direction of the applied force. It means if I apply a force in this direction to this body, the change in momentum will take place in this direction. But if I come from this direction to apply a force on this body, the change in momentum will take place in this direction. That is simply what Newton is saying. The rate of change of momentum is directly proportional to the applied force. The rate of change of momentum with time is directly proportional to the applied force and takes place in the direction of the applied force. So that's what Newton is saying in essence. So in our next video, we'll be looking at simple basic problems in Newton's second law of motion. I believe you've been able to learn one or two from this class. Please join us in the next video and as we look at related problems. Thank you for watching.